Good morning, Good morning, children. Today, let us complete surface chemistry. Now, yesterday we discussed all the properties, optical properties, Tyndall effect, and electrical properties, Brownian moment. All these properties we did. Today, let us discuss coagulation. Now, what is coagulation, children? Coagulation may be defined as the colloidal solution we have to bring into precipitation, or we can also say the conversion of colloidal solution, conversion of colloidal solution, conversion of colloidal solution by the addition of suitable electrolyte is known as coagulation. So simple language में कोलॉइडल सॉल्यूशन को प्रेसिपिटेट में कन्वर्ट करने के लिए द प्रोसेस इज नोन एज कोयागुलेशन. So how will you define technical terms? Coagulation may be defined as to bring about the conversion of colloidal solution into precipitate by the addition of suitable electrolyte. I'll repeat. Coagulation may be defined as the conversion of colloidal solution into precipitate by the addition of suitable electrolyte is known as coagulation. So the coagulating power of an electrolyte, it depends upon the nature of the electrolyte and also colloidal solution. Now, when we are adding an electrolyte to the colloidal solution, the ion which is present in the electrolyte is responsible for the coagulating power of a colloidal solution. So, different electrolytes are having different coagulating power. Okay. For the first time, Hardy-Schulze, he studied the coagulating power of different electrolytes on different colloidal solution. Under his name, it is known as Hardy-Schulze rule. Okay, Hardy-Schulze rule. Now let us discuss what are the points of Hardy-Schulze rule. According to Hardy-Schulze rule, the ion carrying the charge opposite to the Sol particles are effective in causing coagulation of the Sol, and the coagulating power of an electrolyte is directly proportional to the fourth power of the valency of the active ion, that is ions causing coagulation. The greater the valency of the electrolyte, the ion which is present in the electrolyte, greater will be the coagulating power. I'll repeat, children, Hardy-Schulze rule. According to Hardy-Schulze rule, the ion which is responsible for the coagulating power, greater the charge on the ion, greater will be the coagulating power. The coagulation is also known as flocculation. The coagulation is also known as flocculation. So what is Hardy-Schulze rule, children? According to Hardy-Schulze rule, the ions carrying the charge opposite to the Sol particles. What is that? The ions carrying the charge opposite to the Sol particles is responsible for the coagulating power of the coagulating solution. Now, greater the charge on the electrolyte, greater will be the coagulating power. For example, to coagulate the negative Sol of arsenic oxide, arsenic is negative charge, decreases in the order. Arsenic oxide में negative charge is there. Al plus 3, Mg plus 2, Na positive. Now, aluminum is having the greater charge So the fluctuating value or the coagulating value will be greater, followed by magnesium, followed by sodium. And to coagulate the positive soul. So the decreasing order of the electrolytes are FeCN6 minus 4 greater than minus 3 greater than minus 2 greater than minus, irrespective of whether it is a positive or negative. Irrespective of whether it is a positive or negative, greater the charge. Try to understand, children. Greater the charge, greater will be the coagulating or fluctuating power of an electrolyte. Okay, children, this is one of the most important question. What is coagulation? 1 mark question. Hardy-Schulze rule. Describe, discuss or explain Hardy-Schulze rule. 2 marks question. Okay, children. Now next, let us start emulsions. Now children, what are emulsions? Colloidal solution, what we have studied, one solid component and one liquid component. Now here emulsions are, both the solutions are of the liquid phase. Okay children, clear? Emulsions may, both the solutions are of the liquid phase. Emulsions are the colloidal solution in which both the dispersed phase and dispersion medium are liquids. Emulsions are the colloidal solution, both dispersed phase and dispersed medium. Dispersed phase and dispersed medium. Both are liquid components. Butter is an example. Milk is an example of emulsion. Milk means the fat is floating in the liquid component. All the cold cream, vanishing creams, and the boys what we call to set your hair, the gel which is used, all these are emulsions. Milk is the best example you can remember. Cold cream, vanishing cream, all these are the examples of the emulsions. What are emulsions, children? Emulsions are the colloidal solution in which both the dispersed phase and the dispersion medium are liquids. Or we can also say, children, emulsions are liquids. Liquid colloidal system. Now emulsions are of 2 types. Oil in water. Emulsions are of 2 types. One is oil in water and the second is water in oil. Children, emulsions are 2 types. Oil in water, water in oil. What is the meaning of this? It is not same, children. Oil in water may, in this case, oil acts as the dispersed phase. Dispersed phase means oil is a dispersed phase. Means small amount. Dispersed phase. Oil acts as and water is the dispersion medium. Is the meaning, what is that? Small amount of oil is dissolved in water. Okay children, clear? Now next is water in oil. Now oil in water examples are vanishing cream is an example of this. Water in oil, water acts as a dispersed phase while oil acts as a dispersion medium. Now examples are, we can give, now this is also known as oily emulsions. What are these? Oily emulsions. Water acts as a dispersed phase while oil acts as a dispersion medium. So such type of, now here water in oil may ulta hai na. Oil acts as the dispersed phase. I think water acts as a dispersed phase. Here water dispersed phase. and oil acts as the oil dispersion medium. Now oil is in large amount and water is in small amount. Such type of the emulsions are called oily emulsions. Oil mean in the large amount and water is in the small amount. Such type of the emulsions are called oily emulsions. Is it clear, children?